Good evening. Today is Monday, February the 1st. Today in pre-calculus, we looked at ellipses. Tomorrow we'll look at circles. So I'll share my screen and show you the type of problems that we're looking at with ellipses. Okay, to start with, if we look at an ellipse, we look at an ellipse, we start with a point which is the center of the ellipse, and it would be some set of coordinates h and k. Then we have a major axis. In this case, I'll draw the major axis along in the x direction here. So this would be a point here, which is one of the vertices, and it's going to be a distance a. So this would be the point h plus a and k. And then we have a point on the other side, which would be the same distance back over here, let's say about right here, which would be h minus a and k. So that would be your major axis. Your minor axis would be in the other direction. So let's say we're coming up here. So this would be a point which is h and k plus b. And we would go down a distance, the same distance. So we would look, it would probably be about right here. So this distance would be h and k minus b. Now we would draw our ellipse through these points. So in this case, the major axis is along the x-axis. So if I draw this thing correctly here, it would go like that. Now, the only other thing we have are the foci. So we would have a focus here, and this point right here would be h. In this case, it would be h plus c, because the foci are a different c, a distance c rather, away from the center. And then the focus over here would be a point which would be h minus c and k. Now, so that's the general layout of the ellipse. Now, if you have an equation in standard form, for instance, let's say we have an ellipse, and here I'll go ahead and erase this. If you have a question, you can stop, pause the video and look at it. But we'll go ahead and erase this, and I'll show you a type of problem that you can run into. So if we look, and we can come back, let's say, okay, we're going to look at a point. I'll go ahead and I'm going to put my division lines right across here. Okay, that's going to be one. And then I'll have a second one right across here. And then I'll put the equal sign. Now, in the standard form, the ellipse on the right side here is equal to 1. So that's a 1, okay? Now, so if we go back now, so we'll put in here, let's say we have x plus 2 squared over 16. And then we're going to have plus y minus 2 squared over 25. Okay, now what you have here, 16 is b squared in this case, and 25 is a squared. So if we look at how we go from here, we would draw our axis, and then we look. So you see the center is h and k. So in this case, the center here, the h value is minus 2. It's opposite because if I said x plus 2 equal to 0, I would get minus 2. And this right here is 2. So the center is located at minus 2 and 2. So this is the point here, which is minus 2 and 2. That's the center, okay? Now, what you do when you graph your ellipse, you look at the number. The number under the x coordinate here, or the x term, is 16. That's the square of, in this case, b. So you go left and right the square root of that number. So we would go left, we go right 4. So we come over here to a point which is 2 and 2. That's right 4 from the center. And then we would go left 4 to a point about right here, which would be minus 6 and 2. Now, the number under the y term is 25. The square root of 25 is 5. So that means I would go up and down 5. So if I go up 5 here, I would come up here to minus 2 and 7. And then I would go down the same distance. So that would put me about right in here. So this is going to be minus 2 and minus 3. Now, so those are my vertices. So once again, if I can do this with this drawing, I can come around like this. And I can go through that vertex, and I can come around and go through this vertex. And then I can come around, and you can kind of see my top point is a little bit high. But my major axis in this case is in the vertical direction. Now, the difference between the center and the focus is c, and c squared is always, for the ellipse, c squared is the difference between these two numbers here. It's the difference between 25 and 16, which is 9. So that means that c is 3. So there I have, so I would go up 3 from here. So I would go up to minus 2 and 5. That's one of my foci. Okay. And I would go down 3 to minus 2 and minus 1. So when I'm drawing my ellipse, those are the points. I show my center, I show my 4 vertices, and my foci, which are always on the major axis, and the major axis is always the axis which has the larger of these two numbers. If the 25 had been over here, then the major axis would have gone sideways. So that's pretty much what we did today in class. Now, the one thing you have to do, and we'll look at that tomorrow more, this is what's called the standard equation. The general equation is something of the form ax squared plus cy squared This is a general equation for any conic section, which are the parabolas, the hyperbolas, the circles, and the ellipses, plus dx plus ey plus f equals 0. So now if you look in your textbook, you'll see some examples. Say you have to be able to start with this general equation and complete your squares on your x terms here and your y terms to get this general equation into the form of the ellipse up here. This is the standard form. So you start with this type of an equation, and when you take your test, you will have 4 problems, 1 of each. So you'll have to do 1 parabola, 1 ellipse, 1 circle, 1 hyperbola. Go from the standard form here, or the general form here, to the standard form, and then draw your picture. So we'll be back tomorrow night, and we'll look at graphing some of these equations a little bit more. So if you have any questions, I'll go ahead and stop the share here. But if you have any questions, as always, send me an email. Let me know how you're doing. Keep me posted so that I know if you're having problems or if you're communicating with me, so we can keep in touch and help you to accomplish the things you need to accomplish. So hope you're doing well, and I will talk to you again tomorrow.